Definition of overlay. Everybody knows to read. But the idea is that we take pieces of the program, put it separately in resources, and then we load those pieces into the main memory, and from there we can work with it. This is our memory map. You can see the 24K that we have on Pebble. In the beginning, there is a very small piece of header, which is the APP info. Now it's the process information. And we put our overlay area in the beginning. This way, when it compiles, it takes those stuff first, so before other things, so it will be there. And the rest of the program is afterward. And when we are compiling, it compiles all the overlay to be sitting somewhere in here, all this area. And we take this area out, and then we put each one of them inside, according to what we need to do. The size of this overlay section will be according to the biggest size of the pieces that we are putting in. So what we have to do is divide the program. The easiest way is to take the parts that we want to put away and put each of them in separate file. And then we take those files and we define sections. Each name of section, the files that will go into it, it can be more than one file. It can also be library. So we don't really need to get a source code. We can use library. So each one will go into its own section. Yeah, we missed one, right? The menu? I think we missed the general step overview. This one. This is the build process, one by one, and that's the step we are going to go over. So, like I said, first we generate the LD script. The trick with overlay is using the linker. After the end of compilation, each part is compiled, and then the linker is putting it all together. And we are preparing first the linker script. So according to this, the linker will be generated. And this is an example of the linker script that was generated. At first, we are generated some initial file that we don't position things in the right place, because first we need to put it all, to prepare everything. So we can measure, we can know what is the size of everything. So the size are here. Huh? Okay. So those are default sizes that we put in. And, and here, this specific overlay requirements is making sure that each one of the parts that will be in overlay will be independent from the other parts. Because, of course, if you want to load several different parts, it can't be that one of them will use function from the other when it's not loaded. So this will be created for each one of the section and, of course, generated automatically. Then we just build. We are doing the first build, and everything will go into their default location to the and after And after we are doing the build, we can check all the section that was created, and from those sections, we can see the size of each section and find which is the biggest section, and accordingly define what is the size of the overlay area. And from this, we also produce later a table that includes all the overlay data. And in this case, we find the maximum size. I think I need to do it like this. Yeah. So then we generate the final LD script, and you can see the size here is 1D. That includes the tiny header in the beginning. And after that, at 1D will be positioned. From 1D will be the main program, and just in case we define the length to the size of the program in this case, but I think it's not so necessary. The size of the main. Yeah, I think it doesn't matter too much. And the overlay will start in practice, like in the position in the file, the overlay will go after the main program. But each overlay section is compiled to be running from the area in the beginning of the memory, but it's stationed starting at this address. Of course, all this is done automatically. So you don't have to worry too much if you're using if you use Gregory's nice build script. Inside the build script, it's also generated automatically the table that shows the location of each overlay section within the generated file. And after we generated the file, we just do another build, and this time it will go to the correct place. The code is compiled into its correct addresses, so we have to rebuild it because otherwise the address will not turn out correctly. And then we take the overlay that, as I showed in the beginning, it goes into the ELF file, and we put them in the resources. We prepare them to build resource file that we put them there. Currently, we are doing it all in one file, but it can be separate files. And after we prepare those files, we can build again, and this time we have the resources that will be compiled into it. And in the end, we trim the resulting file because we don't need the overlay to be part of the program. If the size is not big, it doesn't matter much, but we really don't need it there because we have it in the resources. And let's go back to the map. Okay. When I'm doing the compilation, this part goes here. It doesn't bother me here, but it's better to trim it because I don't need it because those stuff are going into the overlay, so I can load it from there. So that's about the trimming. Too many of them. was here? Yes, okay, I can continue. Yes, the application is ready, and this is what we showed you before. In this case, we have 49K, but in practice, as you saw, we are only getting up to, what was it, 4.8, I think it was. So we are using about half in there. So in practice, we are really using only small part of only less than half of the memory in there. I can look at it again soon. So most of this is not really used. It's just including all the overlays. I will look at the compiled file later. Then in the program, this is the program part that loads the overlay. It just go to this address, which is right after the header, and it reads according to the overlay ID. It's like the first overlay, the second overlay. The address of the overlays are in the table, so it just load from resources directly into this pointer of memory, which is the memory that I allocated for it. This is the exact address that it should start with, so I just load it from resources directly into there. And I'm calling the function with the number of the overlay that I want to load, and in this case, I have I'm loading it in here, and if I get I'm getting back the size that was loaded from resources, so I'm just logging. Of course, I'm running. After I'm loading, I need to know what to run from there. So this is my entry point. And if the size is smaller than 0, I have some error. I guess I need some error code. This is just an example. And of course, I'm saving which overlay I just loaded in case it's needed. This is an example of one of the most popular application. And I looked in the log, and I can see that from all of the 24K, it's using 3.6K. I mean, 3.6 is left for the heap, and out of this, 3K is used. It means he's only got 600 bytes. He's putting pretty many things, and you only have 600 bytes. And actually, if he used overlay for this, he could use much more things. You only have 600 bytes left, and he could have many K left in here. In order to work in overlay, there are several problems with the API of Pebble that will fail. It mostly happens with the data that their size is not properly defined. Like, for example, array of strings that is not defined. It have to create some type of pointer table to know where each one is starting. But and this doesn't go correctly into overlay. So those are four types of issues that we found that if you have it in your code, you have to fix them. The first one is the most common because everybody uses a string. So you actually have to make sure that each one of your strings is defined by its size, by its exact size, and you can't leave it. Also for GPath, if you are using the fill command of GPath, then you have to do it. If you don't use it, you use them. So the data of GPath have to be initialized not in overlay. So you kind of have to split into two files. One is the file that does everything, and one is a file that does only the initialization of the data of the GPath. Same with the vibe. We just make another file that have the do vibe function separately, so it have the pattern in there, and also menu set layer. All those all this is written in the README of our demo project, and we will show the location soon. Let's talk about the challenges. Quite a few challenges in here. One of them is the issue of the slot of overlay. Currently, we are working with one slot of overlay. We can work with more than one. It is important to emphasize that each one of the parts that goes into overlay have to be able not to rely on any of the other parts that goes to overlay. They can't call each other. Well, only one of them is loaded. So if you want more flexibility, you will need either to put things in the main program, the stuff that you need to call from others, or you can actually have more than one overlay slot, and it's a little bit more complicated. One thing we didn't finish is the debugging information. If you have a crash, for example, of overlay part, you will not know, you will get the address, but you will not be able to translate it correctly to which of the overlay pieces was running at the time. I mean, if you know, you will be able to translate it manually, but we don't do it automatically yet. In the App Store, there are several applications that are running with the overlay. Finally is my application. The reason that I started with all this, I made application that display many watch faces, and with a special menu to select between them run by accelerometer and so on. And when I was using only like 6 or 7 of them, I was already really stretched with the memory and tried all kind of optimization that I could do, and eventually I went in the direction of overlay, and this was the final solution. Now I have 12 watch face, and I can actually add much more. I mean, in resources I haven't filled more than half yet, so I can really put much more. I made, as example, I made the point of sale concept demo. The idea is that in point of sale, we can have application that will, or a watch face that will circulate through various watch face of various developers. So when you try to sell Pebble, you can give them this display that shows many watch face, each one with its own uniqueness. And any developer that wants can contribute his watch face to this project. And if Pebble are interested, they can distribute such applications, such watch face to those shops that sell it. So it will keep running those popular displays to potential buyers. Could be nice. It can also be used as a way to demonstrate to user what your application. You can put all your application. He will load one thing that loads them one after another and shows them, and see what you have. we have, and this project have all the explanation, and it have two more attached project that shows how to convert a watch face to get to work with this project. It also shows how to convert into library. And if you want to convert into library, there is also some difficulty how to manage the resources that coming separately. So we did some solution that uses offset. And the other example is the Pebble demo, which also exists in the App Store. This one is basically showing all of Pebble demo, the watch face and the application by menu, and all of them fit inside, and it's really big. The 40K was from this one. I think that was the last one. Yeah. Ah, yeah. Okay. What else? Ah, of course. Can you show the generator screen? Yeah. Can I show the? Can I get camera? Okay.
Grégoire, can you unplug your computer? Yeah. Oh, thanks.
Okay. Yeah. What do I need? Okay. So this is an example of an application that we made. This is the display generator. Everybody knows the popular generator Paul made. We came with the concept that we can take a watch face from any developer and put them in here, and then the user can bundle a bunch of them into his watch according to what he likes. So, yeah, now everybody knows my pattern. So I just select, unselect whatever I want, and I press install, and the installation failed. Just in case. Any idea? No, the application is there, so it should update it. But it's possible I have no communication. No, I do have communication. Okay. So the installation is, I try again. Okay, one last time. Okay, I give up on it for now. Should I reload the page? I will try to reload. It's not so important. I mean, it's not that important. I can choose everything in here. It will all fit inside. Oh, what was my IP? What was my IP? 21? 20? Yeah. One, 3, 4. Yeah. Yeah. Okay, one more try. Let's see if it works. I think it does work. Oh, I need the light in here. Running? Okay. Okay. So it's loaded, and this one is with tap. Ah, good. So here, how do you do tap in here? How do you tap?
It's a little hard, but
Ah, wait, maybe it's too late. Just a moment. Let's try one more time. Oh, by the way, this is a PPOS demo that it's running application. It's running the watch face one after another and displays the name, if any. Okay, tap. Yeah. So it just circulates between those, only those that I selected that you saw before that I selected. And I didn't select so many. And okay, my down button doesn't work anymore. By the way, this is my latest application, and I'm just taking advantage of the opportunity. Look how great it is. Yeah, it's my watch, why not? If I wait a few more seconds, it will do the morphing. But I don't know if I wait. Of course, no morphing in here. Only. Yes, and now is the. Did I miss anything, Gregory? Did I miss something? No. So, question. You're welcome.
Can you, and you need to repeat the questions too.
Yes.
Can you have global variables that are shared between the different overlays?
Do I have global variables that I can share between the overlay? I cannot put them inside the overlay, but I can put any common file, any H file that I define something that should be common between them, and each of the overlay file can access it and use this data. I mean, I don't need to put all the data of the application inside the overlay. I can have common file that those applications can read. Yes.
Like is it a fraction of a second or nobody notices because it's just really fast?
Okay, my experience, okay, the question is if I switch, can I switch quickly between the application? My experience is that it's very fast. Loading from resources is very quick operation, so I see no reason to prevent to using it. Even to, when you load a watch face, you can load some small piece from resources and run it, and load another piece and run it. It's like there is no problem. I don't think there is problem to kind of like to do it non-stop. Do you know of something? Some problem? Yes, please.
So when you're designing your overlay, you've got some, obviously the common segment that, like a utility class or something everything needs. If you mess up and try to call something that is, of course, in a parallel overlay, is that something that gets caught by your script builder, by the loader, or is it just crash at runtime?
Yes, the function, the directive that we put in the overlay script is preventing a call from one overlay piece to the other overlay piece. It will give you compile error. Sorry, the question was... what
happens if you have one section that becomes too big?
Yeah, what?
If you mess up because of your proper design of the overlays,
yeah, so the question is about the designing of the overlay parts. What happens if you miss something and you call from one overlay to another overlay piece? So like I said, it will be caught by the linker script. What else? Actually, I heard the interesting question today that something that I was also considering is, can you load the overlay pieces from persistent memory? And the general answer is yes, but you have to remember that you can't load anything that wasn't really prepared for the program, because if it have, for example, a new function, it will affect the size of the, it will need also a little bit different main program if you add the new function, and the size of the main program may become different. And then it kind of mess up everything. So you kind of have to prepare it in advance. Yes?
Would you overcome that limitation when you pass in a struct or function pointers in your edit call? I mean, instead of calling functions from the main file directly, you would then call function pointers of a struct, which won't change whenever.
Yes, I think it's possible to compile, even as a library, that it will have kind of two parts. The one part that you call into, and this part knows how to access the other part, and the other part can change. I think it's possible. Okay.
So does it mean that you must not use any static variables in your
overlays? What question about static variables in overlay? What is static within the overlay part is relevant only to overlay part. What is global to the entire program? That is like if I just put it in some H file that is not included in the overlay, and then and I can initialize it, give it space in some C file that is part of the program if necessary, and then any overlay can access it. So there won't be any problem, I think. Does it answer? Okay. So
We have to.
yeah, finish, yeah. Okay. Like I said, you can look, we don't have the link in here. So you can check out our GitHub accounts, and in there you will find those applications. Thank you very much.